Edit the scene graph, not the latent. Egocentric video understanding usually entangles objects, interactions, and time into one opaque embedding, so you can never tell which action moved which thing. GLEN, from Politecnico di Torino, lifts a video into a sequence of spatio-temporal scene graphs and models every change as an activity-conditioned graph edit. And at the current graph and a text activity, and it forecasts the final graph as a sequence of structured node and edge edits. 3.8 million training-free scene graphs over Ego 4D, and the first model to forecast how an egocentric scene evolves, the forward pass. Take the current scene graph and a text activity. Add 128 learnable node queries, candidate slots for future objects, build a noised, fully connected graph. Pass it through triplet GCN layers that jointly update nodes and edges with cross-attention to the activity text at every layer. A second graph edit encoder then emits a class score for each query against the 1,480 object classes, plus a no-object deletion token, and an edge head decides which edges survive. Hungarian matching aligns predicted insertions to ground truth, that is, the whole edit, the gap it fills. Prior egocentric models mash the whole scene into a single dense vector. 3 problems. You cannot attribute a change to a specific action. You cannot edit a single object without rerunning the whole representation. And a latent shift is not interpretable. GLEN keeps the scene explicit, compositional, and editable. Add a cup, delete a hand, relabel a relation, each is one structured operation on the graph, conditioned on what the person is doing. The falsifiable hinge on table 3. Forecast the scene graph under 3 settings. A static baseline that just copies the initial graph scores 23.17 recall at 100. A 9 billion parameter language model, blind, scores 9.14, essentially flat across every cutoff. GLEN scores 48.49, more than double the static copy and over 5 times the language model. The graph edit mechanism is doing the work. Without it, no evolution. With it, the scene forecast takes off. How the edit head scales with capacity on table 6. Vary the number of learnable node queries from 64 up to 128. Recall at 100 climbs monotonically, 44.73, 45.89, 47.84, 48.49. More candidate slots, more correct future objects. A caveat though, recall at 20, the strictest cutoff is not monotone. The 100 query config dips just below the 72 query config. Specialization helps at high recall, not at the top of the list. Here is the payoff in pictures. Before, an egocentric view of a kitchen counter, a hand reaching toward a mug. The activity, pour coffee. After, the forecast graph edits the scene. The mug node moves to the hand. A new coffee relation appears. The counter relation updates. The model never regenerates pixels. It edits the structured graph, node by node, edge by edge, conditioned on the verb. The activity and the scene together point at the edited future, where the graph representation wins and where it loses, on the EXPLORE bench reasoning suite. 4 metrics. Object score, relation score, attribute score, unique score. GLEN reports only 2. On object score, it is state-of-the-art, 65.59, beating a 63 billion parameter vision language model. On relation score, it is 7th, 2.69. On attribute and unique, it is unranked. One of 4 metrics is a clean win. The object half of the graph is the strong half. 5 honest caveats. First, the relation edit half of GLEN is the weak half, losing to 7 models on relation score. Second, the A-GEF benchmark is the author's own task on the author's own auto-generated annotations, so the test labels share the annotation pipeline's biases and annotation circularity risk. Third, on Ego CBR retrieval, GLEN loses the global recall at 5 to a CBR-trained baseline. Fourth, on Ego schema, feeding scene graphs alone to a language model drops accuracy, 6.8 points versus feeding raw frames. The structure is not free. Fifth, no seeds, no confidence intervals, single-run deltas under 1/10 of a point. Cite the paradigm, scene evolution as graph edits, not a reasoning crown. Edit the scene graph, not the latent. GLEN lifts egocentric video into a sequence of spatio-temporal scene graphs and forecasts every change as an activity-conditioned graph edit. State-of-the-art on object forecasting. Recall at 100 near 48.5 against 23 for the static copy. 3.8 million training-free graphs over Ego 4D. Subscribe for the next breakdown.